All right. So condensing logs is basically the opposite of expanding logs, right? And so whatever the order of steps that we would use when we were expanding logs, we're basically just going to flip that and go the other direction. So when we were expanding, we were trying to take one log and break it apart into logs, and the only thing in the argument, or the only thing that was in like the place that's being evaluated, was a single number or single variable, right? And now our goal is to go the other direction, where we want to pull all of our arguments together. We want to pull all of those exponents in. And so previously we would start by breaking it apart using the product rule or the quotient rule. So that was just the difference between if we were multiplying or dividing, then we would pull it apart as log plus log or log minus log. And then we'll use the power rule to bring the powers out. Well, now if we're going the other direction, we'll use power rule to bring the powers back in, and then product or quotient rule to then stick the logs together and either multiply or divide the two arguments together. So here is number 49 from the homework. Okay, so 49 is 36 log base 5 of 3 minus 6 log base 5 of 8. Right? So right off the bat, before we can condense, we need to check and make sure that the logs have the same base, which they do, right? They're both log base 5. Now, this should be the case if you're being asked to condense, but it's a good idea to check just so that you're in the habit of that. Right? Now, so like I said, we want to go the opposite. So previously, bringing the powers out was going to be our last step. So now to bring the powers back in, that's going to be our first step. So anytime that you've got a number that you're multiplying the log by, this can be brought inside as an exponent of the argument. Right? So the argument is what's inside what you're evaluating. Right? Like this 3 is an argument, or the 8 is an argument. And so we can also bring in this 6 right here as an exponent, right? So the 36 and the 6 are coming in as exponents. And so what that looks like is these are still two separate logs at this point. So log base 5 of 3, but now that 3 is being raised to the 36th power. Okay, so we're just undoing the power rule, basically going the other direction. And the same happens for the other log base 5 of 8, and the 6 comes up as an exponent. Okay. Now, our final step is to combine these two logs together, right? There's no more numbers out front, and so we have to look at the sign in the middle, okay? And the sign is either going to be addition or subtraction. So if it's addition, we're going to combine them back together as multiplication, okay? And we'll look at that in just a moment. If it's subtraction, then that's going to be division, okay? And we'll take whatever the first one is divided by whatever the second one is, right? What I mean by that is 3 to the 36th divided by 8 to the 6th, right? It would be log of numerator minus log of denominator. So we can finish combining these together as log base 5 of 3 to the 36th over 8 to the 6th, right? And that is it right there. That's as much as we can combine, right? Now we've got it all the way down to a single log that contains our whole argument. The parentheses are optional because this is all sort of one term, and so we don't necessarily need them. Okay. There are instances where you may be able to pull an exponent outside of the parentheses. If you are recognizing that and want to try it, fantastic. But this, as it stands right now, is as good as it needs to be simplified for our purposes. Right? I also want to look at 50 just so you can see an example of multiplication, just so you can see that, but it's a very similar process, right? So this is number 50, which would be 3 log base 3 of 6 plus 3 log base 3 of 5. Okay, so again, we want to take the numbers in front and bring those up as exponents, okay, which would lead us to log base 3 of 6 to the third plus log base 3 of 5 to the third. Okay. So now the difference being here that instead of subtraction in the middle, we've got plus, right? And so plus indicates that we would have used the power rule to break them, or the product rule to break them apart, which means that to stick them together, we want to undo the power rule, and so, or product rule. I'm going to keep saying power rule, who knows why. But undo the product rule, right? And so we need to multiply our two arguments together. So that would look like log base 3 of 6 to the third times 5 to the third, right? Just multiplying the insides there. Okay. And this is as much simplification as needs to happen. You could multiply all that together, but ultimately it's going to turn into sort of a large number. And so I would recommend just leaving it as it is, log base 3 of 6 to the third, 5 to the third. Other things that may help you on this section, for example, in 52 and 55, you'll see something like log of such and such over 2. Okay, that can be rewritten as 1/2 times your log of something something, right? So I'm just pulling the divided by 2 out as a multiplied by 1/2, and then you can take that 1/2 and throw it up as a power using the undoing the power rule, and so that'll sort of help you out there. Basically the opposite, right, of taking a square root and turning it into a power. Now we're taking a power and of 1/2, and it's going up, and that's as far as you need to go. So you'll need that for 52 and 53. But looking at the rest of this, you should be able to sort of follow along the same process. 57, for example, not all of the logs have powers or numbers that you need to bring in, so you don't need to do, you don't necessarily need to do the power rule for each log, only the logs that have a number out front of them, and then you'll product rule to bring them all back together, that sort of thing. The final section, I'll have something for you for next week for that, but don't worry about that too much.